Okay, well, in chapter 7, we covered some non experimental designs. Now we're going to look at some experimental designs. Notice that both of those are quantitative, but these are typically more for showing a causal effect. Remember, in the non experimental, we typically were not looking for a causal effect. Um, Sorry, wrong slide there. Uh, but there was the causal comparative option where you use some pretty heavy statistics to try to balance the groups. Whereas experimental, we're really looking for, does this treatment cause some kind of outcome? Okay, so let's go ahead and jump in. One of the distinguishing characteristics of an experiment is we have the power to manipulate the independent variable. Um, so, for example, when we talk about some of the correlational research, an independent variable could be gender. Now, in an experiment, we can't randomly assign someone to a gender unless we're doing some kind of test tube baby creation experiment. We typically cannot assign a gender. Uh, we couldn't usually assign, well, socioeconomic status, certainly we couldn't assign. That's something where you have, at whatever point you enter the experiment, it's already determined. You can't suddenly assign someone to a different socioeconomic status. So there's a lot of things that we cannot manipulate in research. However, there's also things we can manipulate. How much of a drug to give someone, how many hours to have someone study a material. You specifically ask them, or in a lab, you give them 10 minutes versus you give this group 1 hour to study the material. You could do some kind of stimulus where you're providing an electric shock. I did this a couple times to earn some money in grad school where I let them shock me and then read different brain outputs. It's not fun, but earned some money. Okay, so some of the difficulties, typically you will not see a lot of experiments in educational research. And this is because of ethical concerns. It's not ethical to, if you know some kind of intervention is effective, it's not ethical to randomly assign students to not get that intervention. Also practical. In education, students are grouped together already in classes a lot of the time. So to randomly assign them two classes where one will get a certain type of treatment and one will get another type of treatment, you would quickly raise parental concerns. And if you're a parent, you would probably be concerned also with your student. So it can be very difficult. It's occasionally done if we don't really know if a treatment is very effective, if there's an easy way to randomly assign, but you won't see it a lot. Another problem with experiments that's not talked about as much maybe is the external validity, and we'll get into that in just a second more, but experiments tend to have very high internal validity when conducted well. So in other words, we can say that a treatment is effective, but when we go to say who is the treatment effective to and when and where and questions like this, generalizing it beyond the sample, it tends to get a lot weaker. Whereas in some correlational studies, we may have very high external validity but low internal validity. Okay. The book goes into 11 different types of internal validity and 5 different types of external, and it would be great for you to read those. Right now, I just want to hit the main difference. So internal validity is, to what degree does this independent variable that we're studying actually cause some outcome we're looking at. For example, if we're in a lab, taking this pill lessens the time to when you get relief from your headache. In an educational study, maybe giving this one computer-assisted tutoring system for 1 hour increases test scores by 5 percentage points. But when we talk about external validity, we want to know, okay, we have our statistical results. Now, who do they apply to? So internal is how much does this treatment actually work? And external validity is, now that we have a statistical result, who and where and when can we generalize the results to? So taking the example I just had about this computer-based tutoring system, you do 1 hour of it, increases your test score by 5 points. Well, maybe in the lab, but how does it work once you take it to a home where there's very slow internet connection speed, or maybe there's distractions all over, people talking, checking the cell phone, checking on Facebook. Maybe suddenly that effect of 5 points becomes 1 point, or it's possible it would even become negative. So internal and external validity, both are very important. Experiments tend to be very good at internal validity, very poor at external validity, and vice versa for most of educational research will tend to have, well, at least large-scale educational research will have better external validity and not necessarily as much internal validity. So we need a combination of both is very helpful when possible. So these 4 designs we're going to take a quick look at. I'm pausing here. I'm just thinking there was one more thing I wanted to mention in validity. Maybe I think it's later in the slide, sorry. Okay, so the 4 different designs, experimental designs. In all of these R will be random, and that's what I wanted to talk about, and that will be on a slide. So this is either random selection or assignment. In these designs here, it's always going to be random assignment. What group are you assigned to? O is some kind of observation where you're collecting a piece of data. X is a treatment, so this could be that tutoring, 1 hour of tutoring online kind of thing, or it could be medical drug. And A, B, or C are the different groups. So each of these is part of your sample. Pre-experimental designs, horrible. They don't really do much of anything, but they are out there. If you see a report written with this, you should be very, very cautious about any claims that are made. So let's just look at this here, the post-test only. A, so we have a single group. So maybe we collected 30 students by volunteer. It really doesn't tell us how the students are selected. We give them all some treatment, and then we measure the outcome. We don't know where these students started from. We don't know what would have happened if we didn't give them an outcome. It really doesn't tell us much at all. It's a horrible design. This is a little better, the second one, where we have an observation, then some kind of treatment, and then another observation, often called the pre-test, post-test. So you have a group of students, maybe your classroom, for example, when you're teaching. At the beginning of class, you give them all a test on how much knowledge they have of literature. Say we're in Shakespeare, how much do they know already about Shakespeare? Then you give them the class on Shakespeare throughout the entire course. And at the end of the class, you give them a post-test and see how much they know. And hopefully you would want that post-test to be higher than the pre-test. Can you say that that was a direct result of your teaching? In that case, it would be fair to somewhat say that, but we would still have a lot of internal threats to validity. They could be learning other ways. If it's the same pretest and post-test, they may have learned what was on the pretest and then specifically studied those, so it doesn't really represent their overall understanding. Non-equivalent groups, so here the nice thing is you have two different groups, and you're giving one the treatment and not the other group the treatment. The problem here is these two groups could have been very different to begin with, and whatever they were different in, whatever characteristics, could have been the main reason there's a difference in outcomes. Okay, now here we're getting into quasi-experimental, and these are a little bit better. Notice they still don't have any R showing up. We don't have any random assignment, but we do have this observation before the treatment was given to the first group, and an observation to this group even though there's no treatment given. This helps control a lot of things. We can see, were there differences in A and B before they ever got the treatment? Because this gives us a glimpse in before we administer the treatment. However, it still doesn't, we can control for those statistically, but it's not the same as having two balanced groups, two equivalent groups to start off with. We can maybe adjust, these A were much stronger in English coming into the treatment than the B group, so we're going to give the B group kind of a handicap in their scores, but it still doesn't really tell was this treatment effective for anyone because these groups were not originally balanced. And here is very similar, except you have two treatments instead of a control group. Selection bias, again, is the major concern there. Random assignment, let's start with random selection. Random selection is how are you choosing the people to be involved in the study. Random assignment is how, once you've chosen your sample, how are you dividing them into the groups. Real quickly, random selection is great for raising the external validity. Random assignment is great for raising the internal validity. Because when we have this randomization, these are the same as the quasi-experimental, but with a random assignment to group. Because of that random assignment, we're going to have generally balanced groups on any variable you can imagine, so that the only difference between A and B now is that A gets the treatment, B doesn't. So when we look at the differences in outcomes between the A group and the B group, we can say whatever differences they are, they're probably because of this X, not because of differences that existed beforehand. Whereas we could not make that strong of a statement on any of the other methods. Final thing I want to look at is factorial designs when you have more than one independent variable. And there's two types of effects that you would have here. The main effect is the independent variable itself effective across the board for all different types of groups? Or you'd have interaction effects where, okay, maybe this independent variable is good for guys but not for girls, or maybe it's good for elementary students but not for middle school and high school students. So how do you notice that when you're looking at a graph? Well, a main effect, so here we have three different types of fertilizers, how much was harvested, and the colors I know you can't see very well. The blue is wheat, red is corn, purple's rice. And notice that in general, the rice, this purple, is getting more effects than the blue, the wheat. So we might say that there's a main effect for type of crop. We might also say there's a main effect for fertilizer blend, because notice that when we're going from brand 1 to brand 2 to brand 3, in general, we're going up. If we took averages, I bet we see that the average harvest amount is highest overall for brand Z, the third brand. And finally, notice that when we're looking at do all of these lines have the same slope? No, the soy does not have the same slope. So it doesn't matter how high it is compared to the others, but if it doesn't have the same slope, we call that an interaction effect. Finally, we have single subject design. which I'm going to let you read in the book.